Let's say we have here a chamber like this, and this is filled with liquid all the way, right? Let's say we have some weight here, which is acting here. I'll call this weight mg. Let's say the height of the chamber is h. Let's say that the area of cross section is a, right? Because this is the cross section area. Now you know that this is filled with liquid, and the density of the liquid is, let's say, rho. Rho is the density of the liquid, right? Okay. आप लोगों को ये बात पता है that pressure is force divided by area, okay? And we can write here in the place of pressure P, and this is force is W, which is the weight. This is the area. This weight is mg. We have area here, right? And mass can be written as density into volume. ठीक है, mass density into volume होता है ना, तो मैंने यहाँ पे mass की जगह density into volume लिख दिया, ठीक है? और एरिया यहाँ पे आ गया. दिस इज द डेंसिटी, दिस इज द वॉल्यूम. और हमें पता है कि ये जो वॉल्यूम है, वॉल्यूम क्या होता है? एरिया इनटू हाइट होता है ना. दिस इज द वॉल्यूम, दिस इज एरिया, दिस इज द हाइट. So we can write here density into volume into G over A. We can also write here वॉल्यूम की जगह हम लिख सकते हैं एरिया इनटू हाइट इनटू जी ओवर ए. ये एरिया एरिया से कैंसिल आउट हो जाएगा, ठीक है? और प्रेशर वुड बी रो जी एच. अगर आपने किसी लिक्विड में से एक कंटेनर लिया होता, एक पूरे लिक्विड कंटेनर में से लेट से एक कंटेनर लिया होता, तो आप वहां पे हाइट को डेल्टा एच लिख सकते थे. तो आप यहाँ पे एच का डेल्टा एच लिख लेंगे, तब भी आपके पास प्रेशर इज इक्वल टू, द चेंज इन प्रेशर इज इक्वल टू रो जी डेल्टा एच आ जाएगा. So this tells us what that pressure depends on three things. That is the density of the liquid or the fluid, the depth of the liquid column, and the gravitational field strength. These three things are responsible. Area देखें, area कहीं पे भी इसमें use नहीं हुआ. Area cancel out हो गया. Area has been cancelled out. If we have something of this sort, let's say we have a container which is like this. This container is filled with liquid all the way. I label here various points. This is point X. This is point P. This is point Q. This is R. Right? So we have these various points here. तो आपको पता होना चाहिए that pressure at X, P, Q and R का क्या होगा? It would be the same. The reason is, even though the areas are different, the pressure is the same, since they are at the same depth. So मेरा आपसे question है, let's say we have here a water body. This is a water body here like this. And we have something of this sort. This person is swimming here. I'll call this point A. Let's say the depth at this point is 50 meters. And the density is 1000 kilogram per meter cube. Atmospheric pressure is acting from here. I'll call this P naught. This is the atmospheric pressure. The question is, what is the pressure due to liquid only at A? सिर्फ लिक्विड की वजह से क्या है एट ए. नंबर 2, what is the total pressure at A? ये जरा कैलकुलेट करें. Try this. If we talk about the pressure due to A, then you should know that pressure due to liquid only would be what? Pressure due to liquid only would be rho GH. And rho is 1000, G is 9.8, and the depth is 50. So that is going to be what? That is going to be 490,000 pascals. Right? And if you talk about the total pressure at A, that is going to be P naught, which is the atmospheric pressure plus rho GH. देखिए एटमॉस्फेरिक प्रेशर को आपने नहीं भूलना, आपने लाजमी इसको ऐड करना है, राइट? सो दिस इज गोइंग टू बी पी नॉट इज गोइंग टू बी atmospheric pressure which is 1.01. इसकी वैल्यू होती है 1.01 into 10 raised to power 5 Pascal, right? This is going to be 1.01 into 10 raised to power 5 Pascal plus rho is 1000, G is आपने कैलकुलेट किया हुआ है ऊपर 9.8 into 50. The answer is going to be, इन दोनों को जब आप ऐड करेंगे तो आंसर आएगा 5.91 into 10 raised to power 5 Pascal. The atmospheric pressure will be added with the pressure due to liquid. Is that clear, everyone? एक पॉइंट है यहाँ पे पॉइंट A और एक पॉइंट यहाँ पे है पॉइंट B. पॉइंट A की हाइट है h1, लेट्स से पॉइंट B की हाइट है h2. ठीक है, they'll ask you what is the difference in pressure between A and B. In terms of rho G delta H. You know that this height is what? This is delta H. So what is the difference in pressure between A and B? G is the gravitational field strength. Rho is the density of the liquid. आप इसको लिख सकते हैं डेल्टा P is equal to rho G H2 minus H1. आप ये भी लिख सकते थे ना rho G H2 minus rho G H1. तो ये हो जाएगा rho G delta H, where delta H is what? That is H2 minus H1, right? ठीक है, clear है सबको? There is this thing that how to measure the atmospheric pressure. An instrument for that is known as mercury barometer, right? I'm going to write here mercury barometer. How does the mercury barometer work? We have here a test tube like this. This is a test tube. It is filled with mercury all the way. It's a 1 meter long test tube. And what you do is you take a dish which is filled with mercury all the way, like this. You take a dish like this, and you invert this over here. इसके ऊपर आप invert करेंगे इसको, ठीक है, इस टेस्ट ट्यूब को. जब आप इसको इन्वर्ट करेंगे तो क्या होगा? जो प्रेशर एक्ट कर रहा है एटमॉस्फेरिक प्रेशर, ये मरकरी को यहां तक ये डिपॉजिट हो जाएगी, राइट? ठीक है, और ये जो चीज होगी, दिस इज द वैक्यूम. देयर माइट बी सम लिटिल बिट ऑफ एयर प्रेशर, बट दिस थिंग इज द वैक्यूम, राइट? तो this height that we have is representing what? This is representing the atmospheric pressure. This height represents the atmospheric pressure, right? because the atmospheric pressure is acting here, here, and that will also be acting here. So from here to here, this height represents the atmospheric pressure, right? And now, can you calculate this height? If the atmospheric pressure is 1.01 into 10 raised to power 5 Pascal, and you have the density of the mercury is we have G as 9.8. Can you calculate this height? It's 0.759, which is 757 probably, which is 0.76. तो 0. इसकी height होगी 0.76. आप इसको put कर सकते हैं P naught is equal to rho G delta H. And you know that the P naught here is 1.01 into 10 raised to power 5. Density is 13,600. G is 9.8. And once you put delta H here, this height becomes 0.757, which is approximately equal to 0.76 meters. Okay. So this height that we have is 0.76 meter of mercury. Ag is the symbol for mercury, right? Ag is what we call, you should have known from chemistry as well. Chemistry में आपने शायद देखा भी हो ये. It's a 1 meter long test tube, and this height is 0.76 meter of mercury. We also refer this height as 760 millimeters of Ag as well. Why didn't we use water instead of mercury? What's the reason? हम पानी भी तो यूज कर सकते थे. But why? वाटर की डेंसिटी कम है तो उसकी हाइट बहुत बड़ी आएगी. 10 meters लॉन्ग हाइट आएगी उससे. अगर आप वाटर यूज करें तो डेंसिटी ऑफ वाटर इज 1000 किलोग्राम पर मीटर क्यूब. तो अगर आप यही प्रेशर इज इक्वल टू रो जी एच यूज करें और आप हाइट कैलकुलेट करें तो इट वुड बी प्रेशर ओवर रो जी. So density of water is less, so it will give you a greater height. It will give you 10 times. ठीक है, आपके पास जो हाइट आएगी वो 10 meters तक आएगी इसकी हाइट. आप कैलकुलेट कर सकते हैं. H is equal to pressure is 1.01 times 10 raised to power 5. Rho is 1000. G is 9.8. And once you put in the value, you get the height as 10.3 meter. This is huge. अच्छा, एक फाइनल चीज जो इस चैप्टर में रह गई है, दैट इज वो आगे भी यूज होगी थर्मल फिजिक्स में, तो दैट इज बॉयल्स लॉ. बॉयल्स लॉ के बारे में जहां तक बात है, आपको पता होना चाहिए दैट द प्रेशर ऑफ a fixed mass of gas is inversely proportional to the volume, provided that temperature is kept constant. मतलब आपके पास जो गैस है उसका प्रेशर इनवर्सली रिलेटेड है वॉल्यूम से, अगर आप टेम्परेचर को कांस्टेंट रखें. अगर आप प्रेशर बढ़ाएंगे तो वॉल्यूम कम हो जाएगा, टेम्परेचर कांस्टेंट है. और अगर आप वॉल्यूम बढ़ाएंगे तो प्रेशर कम हो जाएगा, लेकिन टेम्परेचर को आपने कांस्टेंट रखना. सो प्रेशर इज ऑफ अ गैस इज which is a fixed mass of gas is inversely related to the volume. ठीक है, the condition is that it should be at constant temperature. Remember that. So if you have here P divided by 1 over V is giving you a constant, because you divided like Y is proportional to X, so you divided with X to give you a constant K. So P over V will give you a constant here. So this gives you P divided by 1 over V is equal to a constant, which becomes P multiplied by V is equal to a constant. So PV is equal to a constant, which means what? Which means that if you have 500 pascals and 1 meter cube, the answer is still 500. If the pressure is less and the volume is more, the answer is still 500. If the pressure is even less, then the volume increases, the answer is still 500. I mean, it's giving you a constant. So this gives you the important relationship that P1 V1 is equal to P2 V2. Okay, this is a very important relationship, and this is at constant temperature. Remember that. If you draw a graph of pressure and volume, the graph is going to be like this. And if you want to draw the graph of pressure and 1 over V, तो ये कैसा बनेगा? जी, it's a straight line. Okay, it's going to be a straight line.